girls, get down. Get up.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now I'm going to briefly go over some naming techniques to remind you of how to name different structures. And so the first example I'm going to do is pentane. So off the bat from what I talked about before, you see the prefix, which is pent. Since it's pent, you know that it involves 5 carbons. Since the suffix is ane, it means that you have an alkane, meaning that you don't have any double or triple bonds. So this is a very simple structure where you have 5 carbons lined up like so, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens in order to satisfy the 4 bonds for the carbons. So let me just finish drawing this out for you. And remember, the formula for alkanes is CnH2n plus 2. So let's test that out with this. So you have 5 carbons, so n equals 5. 5 times 2 is 10 plus 2 is 12. And that's exactly what we have right here. But this is the molecular formula, C5H12. But I can also write out the structural formula for you, which we briefly went over before. So in this case, I have a methyl group right here, right? A CH3. And then I have a CH2 right here, but we have a couple of them. We have 1, 2, and 3. And so I'm going to write this out as CH2, 3, and then finally another methyl group at the end. And so CH3. So this is the condensed structural formula. And it's really easy to figure out how to write that out when you draw out the structure. So now, based off of this pentane molecule, I wanted to show you guys constitutional isomers. So in the case of constitutional isomers, these are molecules that have the exact same number of atoms. So all of these isomers will have 5 carbons and 12 hydrogens, but it's a different way of attaching the same atoms to one another. And so this is the fundamental unbranched example of what pentane looks like. So you just have 5 carbons lined up like so. And I'm not going to write out all the hydrogens, but I'll draw them out as lines. But we can also have examples where this molecule is branched. So for example, if we have carbon, 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 4 carbons as the parent chain, but then what if I have one branching here? So now I have CH3. But let's make sure that the molecular formula is still the same. We have 1, 2, 3, 4, 5 carbons, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Still 12 hydrogens, so we're good. And so another way we could branch this pentane molecule is by doing this. Carbon, 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 carbon. So now again we have 5 carbons and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these all have the exact same molecular formula of C5H12, but the way the atoms are attached is different, so they're all called constitutional isomers. So by using the IUPAC rules, we can now figure out how to name these different molecules. And so in this case, we have the simplest pentane molecule. And one thing I wanted to mention is an alkane with 1 hydrogen removed is called an alkyl group. So for example, CH4 is methane, right? But when you remove 1 hydrogen from it, it becomes CH3, and this is called a methyl group. And so remember that when you name any of these molecules, the prefix always indicates the number of carbons in the chain. For example, in this case, it's the pent. And then the suffix always tells you the type of compound. In this case, it's an alkane. So this is just a little note for you to remember. So now let's try to name this. This is just pentane, but let's look at this one. We have 1, 2, 3, 4 carbons as the parent chain. The parent chain is the longest possible carbon chain that you can create. And so this is the parent chain. So now, this methyl group right here is considered a substituent. Basically something that's attached to the parent chain. Since it's a CH3 group that's attached to another carbon, it's called methyl instead of methane. And so in this case, we always number the parent chain so that the substituent has the lowest possible number. So in this case, I would make this 1, 2, 3, 4 for the parent chain instead of numbering it 1, 2, 3, 4. And this particular molecule would be called 2-methyl. And then since there's 4 carbons in the parent chain, butane. As simple as that. But because there's 4 carbons, and ane because it's an alkane. The 2-methyl that's put before that name indicates where exactly that substituent lies. So now let's look at this guy. So in this case, the longest possible carbon chain is 3 carbons, right? And so this is the parent, and so now these 2 methyl groups are the substituents. Since they're both in the middle, it doesn't matter which way you number it. I could do 1, 2, 3. I could have done it 1, 2, 3. Either way, they're both on the second carbon. So this guy is going to be called 2,2-dimethyl. And then since we have 3 carbons, it's going to be propane. Prop for the 3 carbons, anes for the alkane. The 2,2 indicates that there's 2 methyl groups in the second carbon position. The di as the prefix also tells us that there's 2 methyl groups. But I'll talk in a little more detail about the substituent rules.
My dog, get up.